Good morning, Algebra. All right, so this section is 10.9. It is exponential functions. All right, so all they're really having you do in this section is use an exponential function to create a table. And so when it says exponential function, what it means is that you have a function where the exponent is your variable, right? So that's your variable. So if we wanted to figure out what some of the points for this function were, the easiest way to do it is to make a table, right? We would say, what's our y value? I'm going to put 2x here because I don't know what that is. And then over here, I'm going to put my x value, all right? And so what I'm going to do on this is, just like with other stuff where we got to pick our numbers, we want to pick the easiest numbers possible. So I'm going to pick 0, 1, 2, and we'll do 3 also. 0, 1, 2, and 3. Okay? So what that means is I'm going to take this equation and plug this number in where there's an x. So I'm going to say 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. Okay? So all I did was fill it out. You don't have to do it this way. You could do a row at a time instead of the whole column, but I just did the row, or the column, so you'll see the pattern. All right, so I'm going to start at the bottom and work my way up. So if you remember 2 to the third power, what that means is 2 times 2 times 2. Okay, 2 times 2 is 4, times 2 is 8. So 2 to the third is 8. 2 squared would just be 2 times 2, so that would be 4. 2 to the first is just 2. All right, 2 to the 0 is a little tricky. You have to remember this property. Any number to the 0 power is always 1, no matter what. If it's like 25 to the 0 power, that equals 1. 350 to the 0 power, that equals 1. Any number to the 0 power is always 1. There you go. That's it. That's all you have to do for this section, is you take the equation they give you, pick your numbers, 0, 1, 2, 3, and plug it in. All right, let's do another problem for an example. So we'll set up the second example they have in the book. So I'm going to be using the book a lot more now since that's what you guys have at home. So I'm going to work through those examples to hopefully give you a little more support, because sometimes the book does not make sense. So the second example they use is y equals 2 times 3x. All right? So one of the first things to notice here is you have to be careful with your order of operations. You cannot say 2 times 3 to the 6th power, or sorry, to the x power. So this is not 6 to the x, right? With our PEMDAS or order of operations, the first thing we do, well, is parentheses, and then exponents. Okay, so we have to deal with all the exponents before we can multiply it by 2. So sometimes you'll see it written like this. Oops, y equals 2 parentheses 3 to the x. And so that tells you you've got to do this 3 to the x first, and then you can multiply it by 2. All right, so I'm going to make our table up. We have our y's. We have our 2 times 3 to the x. And then we have our, I totally wrote this table wrong. It should be, these two should be flipped. Let's fix this. It should be x, y. Should have been that for the first one too. So our x values we're going to pick is going to be 0, 1, 2, 3. Then I'm going to start plugging it in. Okay? So this is going to be 2 times 3 to the 0. 3 to the 0 is what? 3 to the 0 is 1. So 2 times 3, or sorry, 2 times 1 is equal to 2. Go to the next one. 2 times 3, so this 2 is always going to be there, times 3, 3 is always going to be there. The only thing that's changing is the exponent, 3 to the 1, right? 3 to the 1 is 3, 2 times 3 is 6, okay? Our next number is going to be 2 times 3. These two never change. All that changes is the exponent. I'm plugging in this number, 2. 3 squared. 3 squared is what? 9. So this is 9. 2 times 9 is 18. Last one, 2 times 3. We change this exponent 0, 1, 2. This new exponent is this, becomes 3. 3 to the third power. 3 times 3 times 3. This is 9. 9 times 3 is 27. All right? So we have 27 times 2, which is 54. Okay? So something I want you to notice, this is how exponential patterns work. And this is also, well, okay, so 2 to 3 was times 3. 6 to 18 was times 3. 18 to 54 was times 3. You're multiplying by this base number over and over and over again, right? So all it is 2 times 3, 2 times 3 times 3, 2 times 3 times 3 times 3, 2 times. But basically it's the number previous multiplied. Okay, last one. On there we have y equals negative 4 to the x. All right, so I'm going to start off, I'm going to make my table out. We have our x values, our function section, and our y values. So I'm going to take a second to break this up. We know we have 4 to the x. So something that a lot of people mess up is the negative sign. That negative is just a negative 1, and it's in the front. So we do that the very last thing. So that's essentially a parentheses around all this times negative 1. Okay, so that means we're going to do negative 1 after we do this. So if you're thinking ahead, big brain time, all of my numbers are going to be negative. Okay, so let's plug this in up here. We have negative 1 times 4 to the x. All right, so pick our numbers 0, 1, 2, 3. So this is going to be negative 1 times 4 to the 0. 4 to the 0, anything to the 0 is always 1, so this is just going to be negative 1. Negative 1 times 4 to the 1, right? 4 to the 1 is 4. 4 times negative 1, negative 4. All right, so I'm going to stop for a sec, so pause your video, try and fill out these last two, okay? You can either do it the way I'm doing it, or you can look at the pattern. What are these getting multiplied by? What's this one going to get multiplied? What's this one going to get multiplied? All right, so pause for a second. All right, now let's go back and finish these last two. Oh, almost dropped all my pens. Okay, so we have negative 1 times 4 to the 2. 4 squared is 16. 16 times negative 1 is negative 16, or look, 4 times 4, 16. Last one, negative 1 times 4 to the third. 4 to the third power is 4 times 4 times 4. This is 16. Now we got 16 times 4. So you can use a calculator or you can break it up. This is the same thing as 16 times 2 times 2. I can do this. 16 times 2 is 32. 32 times 2 is 64. So 16 times 4 is 64. Don't feel bad if you have a if you're using a calculator for this. Totally fine. Anyways, we got 4 to the third power is 64. 64 times negative 1 is negative 64. So again, times 4, times 4, times 4. That's our pattern. So if you wanted to, you could keep going and filling out the rest of them. That's it for this section. All it is using these functions like this that they give you, and then plugging it in and figuring out what the solutions would be. Oh, quick side note. If they ask for the ordered pair of this section, or for the function, that's just your x and y values, remember? So let's do this. Let's do a separate column real fast on this last one. I'll do it in green. So I would have my ordered pair, which is x, y, okay? So all I'm doing is taking this number and this number. So 0, negative 1. Okay, then I'm going to say 1, negative 4. 2, negative 16. 3, negative 64. And now I have ordered pairs that this function would produce, which this can give you something to graph, which is what you'll do in the next section. Again, pretty easy. That's it for today, and I will post another video tomorrow. Hope you enjoyed. Please let me know if there's anything I need to change or doesn't work, like if these markers are too hard to see, anything like that, let me know. All right, thanks, guys. Have a good one.